Okay, so this video is going to be a little bit shorter. So now we've learned how concentration can affect the equilibrium constant. We learned how temperature can affect the equilibrium constant. And now there's just one more thing that can affect it, and that's pressure. Okay, and there's a pink box on page 503, and it says, when pressure is raised, an equilibrium will shift away from the side that has more gas molecules. When pressure is lowered, it'll shift towards the side that has more gas molecules. If there are no gas molecules, the equilibrium does not shift when pressure is changed. All right, so all that tells us in shortened words, okay, when pressure increases, okay, then that is going to, so that means equilibrium, I'll just shorten that, equilibrium shifts towards, equilibrium shifts away from more gas molecules. All right, that makes sense. If you have more gas molecules, if you increase the pressure, then the pressure is gonna increase on the side that has more molecules. So the equation is gonna shift towards the side that has fewer gas molecules. So it's gonna shift away from where there are more gas molecules. Okay, and then of course the inverse of that is when the pressure decreases, okay, the equilibrium shifts toward more gas molecules. All right, so you need to know that when it decreases, it goes towards more. Okay, so when pressure increases, the equilibrium shifts away from more gas molecules. When pressure decreases, equilibrium shifts towards more gas molecules. And then the last part of that is if gas is not involved, if all you're dealing with is liquid and solid, then the change in pressure will have no effect. Okay, if no gas, okay, pressure has no effect. Pressure has no effect. No effect, okay? So that's the last concept before we go to the acids and bases, and then we will be done.